Hello everybody, we are starting our second to last section today, and it's going to be going over the surface area and volume of a sphere. For this section, we are going to be getting our last two formulas that we will add to our cheat sheet. So moving forward, we'll have one more section, and we'll actually dive back to our similarity chapter, and then we will conclude this chapter and move on to our last and final chapter. This section of notes is unique because our next chapter is circles. So today we're going to be introducing some vocabulary and some equations we will end up using next chapter. So it's kind of like that bridge between each chapter. Before we get started into plugging and chugging in our calculators, we're going to dive into some vocabulary. I feel on my end that most of y'all know what a sphere is. A sphere is a ball. However, we have a more specific geometric definition, and that definition is going to be a sphere is a set of all points that are equidistant from a given point known as the center. So right here in the middle of my sphere, this is my center. All right, and a sphere consists of all different points that are around the outside of the sphere. Okay, even though we're looking at it two-dimensional, technically there would be points, it would be coming out at me right here, and all of these points are equidistant from this center point. All right, I'm going to erase that so we can see a little bit more clearly for other things. Now, the segment that goes or that travels between the center and those endpoints is known as your radius, which we have experienced in the past. So, for example, there's one point here that's equidistant from the center. That will be your radius, this segment. If we analyze the distance between an endpoint on this side of the sphere and this side that's right across from it, that would create your diameter. So we've experienced some of this vocabulary before. The other big term that you will hear is a great circle. Your sphere theoretically can be divided up into many different spheres. So for example, if I have my sphere and I cut it into different sections, if I look at this sphere from the top, it's technically a stack of different sized spheres. Another way I like to think of this is you may or may not have had this recipe before, but if you have, you would recognize it. Have y'all ever had potato gratins? If you haven't looked it up, very good recipe. You take potatoes, like a good old potato, slice it up into tiny little slices, and then you take those slices and you stack them. Kind of creates a cylinder. And then you pour cream and cinnamon over them. Delicious. All right, but a sphere, it consists of those stacked, different sized circles. However, we want to pay attention to one circle in specifically, and that's going to be one that crosses right across the middle. That it's equidistant from both of these sides. And that circle is known as the Great Circle. Why? Because that's the intersection of planes that passes through the center. None of these other planes pass through the center. Only the Great Circle does. And that Great Circle is unique because it divides a sphere into two hemispheres. So it's kind of like our equator. I also like to think of these planes, I like to compare it to longitude and latitude. It's those different segments that kind of identify where we're at on the globe. The other thing that's unique about a great circle is the distance around the great circle. That's the circumference. It's the circumference of the sphere. A little bit of refresher, a circumference is kind of like the perimeter of our sphere, the perimeter of our circle. It's that distance around the figure. So whenever you are referenced the great circle in a problem, you're talking about circumference. Okay? So that's a little bit of fresher, little bit of food on the mind. All right, let's dive into some formulas. First, I want to kind of throw this formula at you. I know it escapes me sometimes, so I thought we'd do a little bit of a refresher. This is not on your cheat sheet, but it's just a little bit of a reminder. Okay, circumference. Our equation for circumference is going to be 2 times pi times radius. All right, so if I'm wanting to find the circumference, which the circumference is also known as the distance of a great circle, I'm going to multiply 2 times pi times my radius, which is 10. So if I were to write this answer in terms of pi, it would be 20 pi, or, let's see, let me type that into my handy dandy calculator, 62.83 meters. Would I square it? Would I cube it? No, because it's just the perimeter. So it's 62.83. Okay, so now moving forward, these formulas will be on your cheat sheet. All right, surface area. Define the surface area of a sphere. We are going to multiply 4 times pi times radius squared. So in this example, I'm wanting to find the surface area of the sphere in terms of pi as well as a decimal number. Let's do a little bit of practice of both because you guys have been experiencing both types of answers. Okay. Here, my diameter is 10 meters. So if I'm wanting to find the surface area of the sphere, I am going to take 4 times pi times 10 squared, which gives me 4 times pi times 100, which equals 4 times 100 is 400 pi. Here would be my answer in terms of pi, but if I were wanting to find it in a decimal number, I would take 400 times pi, which gives me 1,256 point, let's see, if I were rounding to the hundredths, it would be 64 meters squared. Okay, one other thing I wanted to make a note because I have not talked about this previously. You may have seen it in your problems where you have the squiggle equal sign. That's known or it's noted as it's approximately equal to this number. Whenever you multiply something by pi, because pi kind of goes on forever and ever and ever and ever and ever, 3.14 dot 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 dot. Woo! Excuse me. Okay. Because you're multiplying by that really, really long decimal number, we don't know definitively anything we multiply by pi. We don't have a definitive answer. Like it's not exactly 4. It's not exactly 5.25. You know, it could be some other quantity that's slightly off. So whenever you write your answers of something multiplied by pi, you will use the squiggle equal sign. Right? That's not something I'm too particular on. I won't make you lose points for that, but that's why you're seeing that notation. All right, let's do another example. Okay, this is why I wanted to review about circumference because you will see problems like this. How do you find the surface area if you were provided the circumference? All right, so the Earth's equator is 24,902 miles long. What is the approximate surface area of the Earth? Round to the nearest 1,000 square miles. Okay. All right. What is my circumference? What is my circumference? Well, that's 24,902. Okay. That's why you have to understand your vocabulary to understand what are these word problems hinting at. My equator cuts across. It's the great circle of the sphere. So it is, a great circle is the circumference. All right. So plugging and chugging into my equation, 24,902 is equal to 2 pi r. That's what I have. Why am I using the circumference equation. Why is that important for us to find for surface area? Well, for me to solve for surface area, I need the radius. And because I have circumference, I can use that quantity and kind of work backwards through my circumference equation in order to solve for r. So I need to isolate r. In order to do that, I'm going to divide by 2 pi, divide by 2 pi. Now I'm going to plug into my calculator 2 times pi. Gives me 6.2831, Okay, and I'm going to type in 24,902 divided by second answer. So that gives me 3,963.28. Okay. Leave this number in your calculator. Don't erase it, because you're going to want to carry it to the next answer. I rounded here. Okay, so if I just use that rounded quantity, it's going to make my answer slightly off by decimal numbers. Now that I have my radius, I can plug into surface area. So surface area is equal to 4 times pi r, which is 3,963.28 squared. Okay, so now that I already have that quantity in my calculator, I'm going to hit second answer. And then I am going to square that number. Or you could type it in, you can hit the square button. Or you can hit, okay, second answer times second answer. So I get, so we have 4 pi times, whoo, big number, 1,570,755.9.77. All right, leaving that in my calculator, I'm going to multiply by 4, multiply by second pi, giving me a surface area of 1,973,870,17.5 miles squared. All right. Just for this number, we don't have to round to the nearest thousandths of the square mile. I'm fine with that. Okay. Holy cow. So if we were to read that number, let's see. So the surface area of the Earth is 197,387,017.5 miles squared. Holy cow. Okay. All right. Next problem. Okay. Our other equation here is the volume of the sphere. And I want to give a little bit of backstory of where this equation derives from. Because some of y'all are like, okay, why do we have a 4 versus a 10? Or where is this coming from? All right. The volume of a sphere. Okay. When we think of a sphere is theoretically the composition, which I'm going to make this a little bit bigger. Okay. The sphere is technically a ton of different pyramids mushed together. Okay. With the point of the pyramids being in the center and the bases being along the outside. So technically, when we found the surface area, we found the surface area of all these different bases of the pyramids combined together. Okay. So when we find the volume of the sphere, technically we are finding the volume of each of those little pyramids. So technically we could find the volume of one pyramid and multiply that by the number of pyramids that are present. So that's where this equation comes from, okay? While also using the surface area equation. I'm going to make this bigger so we can talk about it for a second. All right, so I take the volume of each pyramid. So that equation is 1/3 times big B, so my area of my base, multiplied by height. Well, the height of your pyramid is going to be your radius because it connects from the top point of your pyramid all the way out to the edge of the sphere. So we substitute H for R. And that's what's happening right here. Ooh, come on, where's my pencil? Oh, my pencil died. Give me a second. Okay. We replace that H by R, and then we multiply by the number of pyramids. All right. My next step is kind of like to rearrange my problem. I shift that in next to big B. Okay, so my number of pyramids multiplied by the area of my bases of my pyramid. Well, we talked about that a second ago. How the bases of all those pyramids, that's the surface area equation, because that's the surface area of that sphere. So instead of leaving it at the number of pyramids within my sphere, multiplied by the area of all those bases, I replace that with the surface area equation. Because most likely when you're given a problem, you're not provided, okay, here's my sphere and it has 100 pyramids within it. No, you're not provided that information. So we substitute the surface area equation into that quantity. Finally, I rearrange to give me my equation for volume. So that's where this jump comes from. Okay, so my volume equation for a sphere is, let's see, it's my pencil. Oh, there we go. We're alive again. Okay, my equation for volume is going to be 4/3 multiplied by pi multiplied by r cubed. All right, let's practice this. I am trying to find the volume of the sphere in terms of pi. So volume is equal to 4/3 times pi times 6 cubed. So 6 times 6 times 6 is 216 multiplied by 4 divided by 3. It's going to give me 288 pi. If I were going to have a unit on this, it would be meters cubed. Okay. Not too shabby once you go and plug and chug it. But am I asking you to know all this information? Absolutely not. I'm not going to assess you, okay, where does this equation come from? However, I just want you to understand where we're pulling these numbers. All right, last example. Just like when we use the circumference to find the surface area, we can also use the volume to find surface area, because really the only quantity we're plugging into those equations is radius. So within each equation, if I can isolate that r to find just r, well, then I can solve for the other equation. All right, so here I'm provided the volume, which is going to be 5,000 cubic meters. Okay, we are wanting to find surface area. All right, so plug and chug. My volume is 5,000. It's going to be equal to 4/3 pi r cubed. I'm going to divide by 4/3 pi, divide by 4/3 pi. All right, so when I type this in my calculator, what I'm going to do is take 4 times second pi, divide by 3. Okay, then I'm going to type in 5,000 divided by second answer to give me 1,193.66, which equals r cubed. That's not just my r quantity. All right, now I have to take the cube root, throwback to algebra, cube root, little bit of tip of how to type that into my calculator. So I'm going to write calc tip. Okay, you are going to click the math button on your calculator in the upper left. I will scroll down to, mine's number 4. It says number 4, 3, cube root, parentheses. I'm going to hit enter. Now I have that cube root in my menu for me to type in. Now that I have that cube root pulled up, instead of typing in 1,193.66, I'm going to click second answer so I can carry that decimal number. That finally gives me my radius of 10.61. Okay, I rounded that number, but carry it in your calculator. Okay. All right. Now for my surface area. What is my surface area formula? Well, that's going to be 4 pi r squared. All right, so 4 times pi times 10.61 squared. All right, time to go back to my calculator. So I'm going to click second answer, squared, which gives me, let's see, 4 pi times 112.526. Multiply that by 4. Multiply that by pi to give me my surface area of 1,414.05. Let's see, what's our unit? Cubic meters, so it's going to be meters squared. So you can, if you have one of these quantities, you can find the other because they are interchangeable as long as you can solve for r. Whoa! I don't know what's meant me. I'm sneezing a lot today. All right, that is all I have for you today. So keep updating that cheat sheet. These are the last two quantities you need to plug, or formulas to plug into your cheat sheet. All right, and your cheat sheet, it's going to be due coming up, so check RenWeb for that.